My name is Mike Wexberg. I'm Executive Vice President of the LA Orange County Audio Society. And we're going to be talking loudspeakers again. So I wish to introduce to you your moderator for this session, a person that I'm sure you're all familiar with, and he'll introduce his panel.
Thank you, sir.
It's Robert Harley.
We need to move up a little bit because we're missing one guy here. Okay.
Follow him? No. Trust me, if I fall off of here, you'll hear it.
I mean, you're on competition after all. We just want to put you off the stage.
That would be nice.
Yeah, I'll stand here. So you guys have enough chairs.
You gonna read Mother?
Hi, everybody. Thanks for coming to the show and to our loudspeaker design panel. We've assembled 5 of the preeminent loudspeaker designers of today. At the far left, we have Richard Vanderstein. Next to him is Kevin Vakes, designer of the Revel loudspeakers. In the middle is Andrew Jones. Next to him is Michael Borison of Rido from Denmark. And at the end, Albert von Schweikert of von Schweikert. And all of these gentlemen have designed state-of-the-art speakers and really high-quality products. In fact, Albert and I once worked in the hi-fi store together in 1980, so we go way back. I had a pair of his garage-built Vortex screens.
Oh, there's a chair. There's a chair.
We need another chair.
Mr. Arnie Nudell just showed up. We'll squeeze him in.
Yeah, that'll be fine.
Okay. We'll share a mic.
Sounds good.
We'll pretend we're in a singing group.
Or something.
And last,
We have the same ideas.
and certainly not least, is Arnie Nudell, founder of Infinity. And creator of the IRS iconic, one of the most iconic loudspeakers. So I'd like to start off by asking each of the panelists to answer one question, then we'll open it up to the audience. So my first question is, how has loudspeaker design changed over the past 20 years, both from a standpoint of how you approach your work and how the products perform compared to loudspeakers of 20 years ago? So, Richard, you want to start off?
Not a lot, really, except for the advancement of materials, being able to do pistonic behavior, where you have...
Robert, volume, can't hear.
Didn't have mic.
Is that better? Not a lot, really, other than the advancement in materials and being able to design cones and domes that offer a true facsimile of what the voice coil is doing at all frequencies. Better passive components, better materials, carbon fiber and such has had a big impact on what we do. But other than that, everything we make is still based on the original research done in the mid-70s.
Thank you.
I think there have been very significant changes in the last 20 years, mostly related to directivity and recognition of the importance of directivity that used to be at most an afterthought, if that. And secondly, the Klippel system coming out, which really took us from trial and error in getting distortion down in transducers. I mean, you'd literally be trying different spiders or different geometries and such to see what got the distortion lower, whereas now we can very, very accurately look at the flux field build and make sure that it's symmetrical and that the voice coil is properly centered in it for low distortion. So really, since then, we've been able to get normal kinds of harmonic distortion below the threshold of audibility. So that's a significant change really over the last decade or so. And the directivity thing is really critical because even with good equalization, if you don't have good directivity, there's no hope for equalization because of the difference between the direct sound and reflected sound.
Well, what's changed for me is the ears have got older. Maybe that reflects what the speakers sound like. But then I'm in good company, so we're okay. I think in terms of understanding the behavior of speakers, we've had the techniques for a long time, but not accessible to many people. You know, all the optimization, the analysis, the synthesis tools. So they're only available to a fortunate few, and the rest was kind of walking around in the dark, trying this, trying that, and gradually learning. Now the process has speeded up, and it's accessible to a lot more people. So you can experiment before you actually build, and that's a huge advantage. So you can get close to your design goal quicker. You still have to then sit down and listen, but you've got to a good way along very much quicker. And I think also the realization that how every single factor affects what you're doing. I think in the old days, we used to ignore a lot of factors that could potentially influence the sound quality. And maybe it's because the transducers of that day weren't up to revealing everything that influences the sound. Now they are, so you have to pay much more attention to every single aspect that you're doing.
I think for us, one of the greatest changes is the understanding of what a speaker is actually trying to do. A speaker plays something that's recorded by a microphone, so it has a tremendous difficult job because it's an E to A converter. It's a converter of electrical energy into something acoustic that's transmitted through the air to somebody receiving it. And what it transmits should be a reflection of what it receives, and that interface is a very difficult interface to understand and interpret. And then behind all that, there's the psychoacoustic capabilities of the people actually listening to the speakers to create an understanding of what is actually going on. And I think that link, that understanding is something that has affected us a lot in the way we design the speakers, the way we understand how the speakers should be tuned, the different curves. And of course also the engineering tools, the modern day engineering tools, the finite element analysis, the analysis tools that you have for making crossovers virtual before you actually build them. Resonance behavior of drivers, how you can look at that before you actually shape a cone or make the materials for the cone. I think those tools have gotten better and more accessible over the last few years actually.
Well, I certainly agree with every statement made. We're all talking about convergence. We know what the target is, and we're all converging on target acquisition. Lower distortion is probably one of the greatest things that have happened because of finite element analysis and computer simulations. So we're on the right path there. At Caltech back in the 70s, we didn't really actually know what a good speaker would be. We didn't know how to design one, so we had to basically hand-build prototypes. Now, as Michael was just saying and the other panelists, you can build it in virtual reality. Of course, it still may not be any good. You have to listen to it and then, do your final tweaking. But the radiation pattern is paramount. Once you've got the distortion down, the coloration down of the entire assembly, I mean, even the wires vibrating in the cabinet, and being stimulated by the magnetic field if you run the wiring too close to the magnets. You have every component in there which is totally dependent on every other component, so it's system integration. And to analyze it, you can use a variety of measurement tools. Dr. Richard C. Heiser, my lab professor, who's quite famous, he invented time delay spectrometry. He kept telling me, well, we don't really know what to measure. There's probably 2,000 or 3,000 measurements that we would have to invent in order to measure an entire sound field. And he said, we can't measure a sound field. We can do a wide analysis of a window. But he said, we don't really know what this all means. So back in the 70s, it was like, prehistoric. You wonder how Kellogg and Rice back in the 30s and 40s and the guys in the 50s at RCA, you wonder, well, what did they do? Well, they were trying to build black boxes. Well, we make the input signal as close to the input as possible. But what's the output of the speaker supposed to be? Well, your radiation pattern, as Michael just mentioned, has to be what was fed into it, and that's the receiving pattern of a microphone. Ray Kimber here knows a lot about microphones and recording technology, and basically he understands that the mics pick up in a certain way, and you've got to be able to use the microphones accurately. And Bob, of course, been making his own records for many years. When we met back in I guess it was the 80s, he had a recording studio. And so target acquisition, lowering and distortion, the understanding of psychoacoustics. If you read the book called Psychoacoustics, written in 1993 by two doctors from Germany, one from Munich and one from Heidelberg, Fastel and Zwicker, they tell you what the ear can discriminate. And so you have a set of standards now that you can follow in order to achieve what the ear-brain hearing mechanism is able to discriminate to. And so I think we're getting closer. Do any speakers sound real yet? Probably not, but they sound good. Every gentleman here makes a speaker that sounds so good that they're selling them by the hundreds. So what can I say? We're all artisans, right? But we have some science that we're using there as well. Now I'd like to turn it over to one of the guys who started this whole thing off with a big bang, Mr. Arnie Nudell.
And it has been that long, absolutely. Can everybody hear me? Well, I have kind of a different take on this. I think that with regard to why, I don't think I'm getting through here. Let me hold it. You can sit. I can stand. With regard to our speakers getting better than they were 20 or 30 years ago, yeah, they are. There's no question about it, and all these gentlemen came up with some very interesting reasons why. I personally think that it is the newer materials that have been developed for a variety of different things that we kind of grab, carbon fiber, Kevlar, these things, were not used 20 or 30 years ago, and I think that those materials are making our speakers better. The problem is I think that there are so many things that we are neglecting. In the past, I think we thought about room-speaker interaction, and I think that we've kind of neglected that. There is kind of a sameness in speakers now about front radiating speakers. Not that it's bad, but I think we can do a lot more. For example, years ago, we made a line source that was 7.5 foot tall, and of course, that's a ridiculous speaker, but if you look at how it interacts with the room, for example, it negates much of the room. If you want to read about that, I don't want to explain it right now, but it certainly is true. You don't get a floor bounce, you don't get a ceiling bounce, you don't get much off the side walls. I mean, things like that. And I think that we have to do more in that area to negate the room, because the room is a major factor. So if we want to make speak, and the other thing that I heard from everybody was distortion. That now we can lower the distortion in so many different ways. I don't believe it in one way. We really haven't done much to lower distortion in woofers. I mean, here's the worst possible part of a speaker system where it's really a motor going back and forth and it's creating all kinds of distortion, and yet we use the same principles. Now, I'm not saying that the way I did it 1,000 years ago is the only way to do it, but it's interesting. In the latest issue of Voice Coil magazine, they give excerpts from the Audio Engineering Society, which is going to be in Poland this year. And I was very interested to see one of the articles asking why, you know, with all the electronics we have today and all the materials that we have today, why are we not trying to make servo woofers again, where it totally lowers the distortion of the woofer all the way down to as low as you want to go, 16 hertz. And speaking of 16 hertz, how many speakers even go down to 16 hertz? I mean, people today are saying that 32 hertz is fine. And once you get to that point, you know, we can't really hear any lower, or there's nothing about the room that affects those much lower frequencies. But if you do have a bass reflex box, for example, and you say that it's down a couple dB, you know, at 32 hertz, let's say, you know, it's down 24 dB at 16 hertz. So there isn't much response down there, and I think that's a loss. So I'm going to stop complaining.
Well, that factor was what led you to found Infinity.
Exactly.
Arnie was a laser physicist, and he couldn't find a loudspeaker on the market that had the low bass extension that he heard when he went to the concert hall. So he built the first servo woofer, mated it to an electrostatic panel, and created the servo static, which is now a legendary product. And he had no intention of starting a speaker company. So a friend suggested he take it to a local retailer. The retailer heard it and said, well, this is amazing. How much, I can sell more of these than you can build. And Arnie says, well, it's going to cost as much as a Volkswagen, which in 1968 was $2,000. And the dealer said, I can still sell more than you can build. So Arnie's built 6 pair or 8 pair, and they sold them, and Arnie quit his job as a physicist and founded Infinity based on that desire to hear low bass and dynamic impact and creating the modern servo woofer. So that's a little aside, sorry.
Thanks.
Digress. Credit where credit is due.
Since Arnie is actually here this year, I'm going to repeat my joke from last year, which was, Arnie is a laser physicist, I'm a lazy physicist.
Hey, I think we're all lazy a bit.
And you have a wonderful British accent.
So I'd like to ask the panelists to comment quickly so we can still have time for questions. Whether you think loudspeaker design is more of a technical endeavor or more of an aesthetic pursuit or some kind of combination. What's the fusion of the technical, the scientific side with the listening and the aesthetic side and the musical sensitivity to listen to what you've created and fine-tune from there? What's that balance?
Musical mics.
Well, for us, the visual never mattered because we just basically built the speakers the way they had to be to do what I was trying to do as far as preserving that waveform as it was launched into the room and to the listener. Later on, found ways to make that aesthetically more pleasing, but...
Well, and aesthetically, musically.
Oh, I see. Well, I mean, obviously, you know, technically, you'd get the distortion as low as you can. You get the radiation patterns uniform, and you try to make the speaker flat, try to behave correctly in time and phase, and then you listen to it and see if it plays music. But in reality, you look at how many different loudspeakers made by pretty bright people, and the sound of them's all over the map. So what you're really doing, or what I did, was built what I liked and tried to back it up with technology and hope to hell enough people like the same thing I did to keep me in business.
Well, and it worked, because the Model 2, I think, is the best-selling audiophile speaker of all time.
A lot of them.
I look at it as a closed-loop system where ultimately how the speaker sounds is number one. So you could say that that's aesthetic, that it's subjective, but those listening tests need to be done in a double-blind controlled manner so that it's more than anecdotal, then leading to the question of how do we measure this so that we can do more of what we thought was good in the listening tests and less of what was bad. So I don't view it as an artistic endeavor, except for the part that as you're listening, I guess you should be well attuned to what would impact your enjoyment and the aesthetic portion, but that it's primarily a technical endeavor.
So, but would you go back and make changes that may result in a better sound but less good measured performance? Would you make that trade-off?
We've never encountered a case where our standard suite of measurements don't get better or not impacted by a listening-only tweak.
So if it measures better, it sounds better?
If it measures poorly, it always sounds bad without exception. If it measures better, that doesn't mean that...
It's going to sound good, right?
Yeah, that doesn't mean that that's an all-inclusive measurement.
I wasn't trying to pin you down.
Yeah.
Yeah, you were.
See, these are fun. I think the question also comes down to what price point do you design at. So when you're designing budget speakers, there's nothing, the speaker isn't technically perfect. Even if we want to say that the best speaker is the technically best speaker, assuming that we know every measurement that contributes to that and we've done sufficient measurements, at the lower end, there is a flavor to it because it's not perfect enough for you to say, done, right? So some people have different ideas of what parts of the spectrum or what aspects of the signal they want to be most accurately reproduced and what they will give up. And that's where the engineer comes in with his or her own prejudices and says, for me this is important, more important, I'll make this part better even at the expense of something else because I can't make everything better. And then you get that designer preference into it, and as you go up maybe you improve all the range, but at the low end you're definitely making those judgments, and again hoping that you've in tune enough with sufficient buyers for that product category that you sell enough to keep you in business.
I think that speakers are not really supposed to be perfect in measurement, because then the flatness of the speaker would stand out, and where you have an overlap between two different drivers playing the same frequency, they always play it a little bit different. You can't have a heavy or mid-range play the same frequency as a tweeter without sounding different. It's as simple as that, and we are sharp enough to pick that difference up, and the trick there is to lower, to have a small valley, or so to speak, in the frequency response to mask that. If you made that perfectly flat, it would stand out and the speaker would sound forced or bright in that area. So we are not specifically targeting something technically perfect. What we have done in Rido is basically we've been working on Arnie's work, because when he invented the emit tweeter, which is the predecessor of the tweeter we have in Rido, he invented something that's so good that no dome tweeter, no cone-based driver can follow it. So the job is there for us to create a mid-range that is as good as the ribbon tweeter, but it's not possible because you have different masses, you have different principles. So for us, making something that sounds flat, meaning that we have to make something curvy in the frequency response. So we sacrifice technical perfection for listening pleasure, so to speak.
As a student at Caltech, we had a student project, and we decided, well, there were 3 or 4 of us that like speakers. We said, hey, we've got a huge lab. We can try anything we want. We'll build anything we want. We'll build the world's best speaker. So we started reading about, prior literature. And we found out about the BBC DIP. The British Broadcast Corporation said, well, if you make the speaker too flat in the mid-range, it's going to sound really forward. So a lot of guys are out there building this British sound, very warm in the bottom and top, and type of a recession, for depth. But that's because those engineers were listening to little tiny monitors 2 feet from their heads in a recording van on location at a concert hall. So we built some speakers with the BBC DIP, and we said, well, this sounds good. It's musical. Let's try some other things. So there were 4 of us, I believe, in the original group. I think 5, and then it went down to 4. I was the only musician in the group. I played piano and violin and acoustic guitar. So we designed a speaker that was roller flat. And our lab professor came in and said, gee, you guys have hit the target, man. The measurements look great. He says, let's hear it. So we turn it on, and he says, that's really bad. We said, yes, we know. We're trying to figure out what's wrong here. Well, it turned out that the radiation pattern had lobes, off to the sides, and you could hear those reflecting off the walls. On axis, it was perfect, but off axis, it was crap. So the thing is I could hear it immediately because it didn't sound anything like a piano. We were using recordings of one of the students playing piano on a Tandberg, I think a TD-20A or some big tape deck like that. And so he says, well, clearly you guys either don't know how to measure it or you're all tone deaf. So I said, well, I can hear that there's something wrong with it. And he said, well, you guys go find out what's wrong with it. So there's some technology and there's some art to the whole thing. And as Kevin said from Ravel there, it's a closed loop. In other words, you have to have the technology to know how to build it, but then you have to have the art to know what you're hearing. In other words, if you're tone deaf and you think it sounds great, but everyone else says it sounds terrible, then you're missing part of the equation there. So I believe that it's a lot of art and a lot of technology, but we try to make everything as flat as possible, off-axis as well as actually. It's actually more important to have it flat off-axis than it is on-axis, because 60-70% of what you're hearing are room reflections. I don't know how many guys listen in an anechoic chamber. Anybody here listen to their system in a chamber, other than all of us up here? We all have chambers. But That's about it. There's art and there's technology. The art is the art of listening. In other words, if you don't know what the hell you're trying to achieve, and you don't know what an instrument sounds like, you're not going to make it, no matter how great you are with test equipment, and vice versa. If you're a great listener, but you don't have any test equipment, do you know how hard it is to design something by ear? It's nearly impossible. It might sound good to you, but it's not going to sound good to the vast majority. And then we'll turn it over to Arnie to see what his thoughts are.
Are you sure?
Absolutely.
First of all, I think you'd all agree that designing speakers particularly is a very, very difficult job. Of all the other endeavors in audio, that one is really rough. It has made crazy people out of very sane people at times. There is one, and of course you hit the nail on the head, I believe, and that is, if you don't know what music sounds like, forget about designing speakers. And when I say if you don't know what music sounds like, you really have to either be a musician or attend concerts, but really have in your head what it is you're trying to achieve. Now, we can talk about a variety of measurements, and of course we have a lot of them these days, but I can tell you absolutely, and these guys alluded to it, that with all the measurements we have, we can't put all those measurements together and make a final product and expect it to sound like music. Remember, we are not trying to design a speaker that puts out just sound or sound effects. We're trying to design a product that conveys music, the emotional quality of music, the emotions of the composer, the emotions of the conductor. And that's when it really becomes difficult, because again, you can have a very flat and a very dry speaker, as these guys have talked about. So there obviously is a variety of different measurements that we really don't know about now to try to convey all those important aspects of music. So I would say that I used to say that it's probably half aesthetics and half technical. I would say even today it's probably 60% aesthetics and what you know about music, and about 40% technical, because the technical stuff, we know, and we use it all the time, and it's kind of second nature to us. So that's what I think at this point.
I would like to just add there that with Albert talking about the BBC dip and Michael talking about a dip in the response, does that mean speakers should have a British accent? Because so I'm way ahead.
All right, well, let's take some questions from the audience. Does anyone have a question? This gentleman in the back, we have a wireless mic coming around, so.
I probably don't need it. If you gentlemen had no commercial constraints upon you whatsoever designing loudspeakers, there are a lot of indications that.
Is that any better?
Much better.
Okay, my bad. There are indications that there are a lot of advantages to powered speakers. In terms of commercial reality, there's a lot of disadvantages because audiophiles like to pick and choose the parts of their menu. But if you didn't have to worry about selling it or the cost of producing it, would you do powered speakers?
Yeah, for sure. We did power speakers for a long time using servoed woofers, for example, but we gave the customer the possibility of, for mid-range or tweeter or both, they could choose their own amplifier. But for a servo woofer, you usually have to provide the power. Now, we did try at one point doing a servoed woofer and maybe suggesting other people's amplifier, and that worked out so-so. Some amplifiers were unstable. Some amplifiers worked quite well. But if there were no constraints, as you suggest, absolutely.
Well, every single company that's tried building a powered speaker, from Philips back in the late 70s, early 80s, to everybody since then, it's a tough road to follow. All studio speakers appear to be powered right now because those guys don't want to put a power amp in some rack. So they do it for convenience. They want to have the little knobs on the front to be able to adjust the bass and treble balance. But I think that the way to do it with perfection would be to have a powered speaker with each driver servo controlled, and actually I'd build a one-way spherical electrostatic speaker and hang two of them from the ceiling, and I would somehow drive the panels with different amplifiers to get the dynamic range up. That'd be a crazy beast, huh? You probably never sell one, but it'd be a lot of fun. Yeah.
That sounds great.
It'd be a lot of fun, but I don't know, the studio guys seem to be adapting towards it. Other private companies that are trying to make inroads with powered speakers don't seem to be doing as well as they'd hoped. So I don't know, I'll turn it over to Michael, maybe he's got a different idea.
I don't know if I have a different idea. I see power speakers emerging a lot as streaming devices where you actually stream directly to the speakers, and they have to be powered in one way or another. I see issues, especially the way we do the tweeter to the mid-range crossover, where we use where we connect the drivers in series and actually divert the current around them. Then we have the advantage that the tiny changes in parameters that happens in dynamic changes that happens as you have excursion on the mid-range driver is also reflected a little bit up in the tweeter. So the coherence of that area under transients remains the same. That is very difficult to do if you make full electronic crossovers. So I think it's a pro and con thing. But of course you will see more and more as you get into Wi-Fi or Bluetooth or whatever power streaming speakers, that you simply omit the traditional hi-fi system and just have the speakers.
Yeah, I think from an engineering aspect, there's a lot of advantages you can get from going powered, but there is the marketing disadvantage. But it comes down to a matter of choice. You start to build your system in a different way. You make different choices as to what you partner the equipment with. So instead of experimenting with the amplifiers, you experiment with the digital source or the analog source you're going to be driving the analog speaker with. So you can still have fun building a system concept around that different technology. But I think the new people coming in, hopefully, I don't see anyone here young enough, but the new people coming in to be audiophiles will embrace the powered concept, because they're coming from a very different angle as to how they source their music and where they listen to it. And so that market, I think, is ripe for powered speakers, even if the traditional audiophile is not, because of apparently limiting choice at the expense of some technical advantages that you can get from system integration.
Thank you. In a New York minute. Absolutely. For one thing, having fully powered speakers would allow me to do my big audio passion of proper room EQ in the loudspeaker. You basically got anechoic EQ above 500 hertz or so, and then you need room EQ below that because it's the room, not the speaker, that you're actually listening to. So it would really enable that. And it's not the first time audiophiles as a group have shot themselves in the foot with this preference, unfortunately.
Boy, I don't know. I think Vandersteen Audio's doomed because our flagship is a powered speaker, and and we've had powered subwoofers in them since they started for the room EQ issues that Kevin just mentioned. However, in our case, it does make our flagship speakers sound better than I've ever heard it with anything else. But people still have the choice. We did decide to put it in a separate box, and but it is designed to do what it's doing, and I think it's a big advantage. And I hope it's not the end of Vandersteen Audio.
I wouldn't worry.
Richard, are you talking about just the powered sub bass or the full range with mid and treble?
range.
Full range,
Yeah.
okay. Well, I'll be at your room
The
later
Model
today
7.
to hear it.
That question reminded me of a question that a magazine editor once asked of Richard Vandersteen. He asked Richard, when are you going to build an in-wall speaker? And Richard replied, when Steinway builds an in-wall piano.
That's great.
That was Gisela from Inside Track.
We have another question. This gentleman here.
Just asking to comment, the full-size big floor standards versus stand mount speakers without board subs. You know, pro or con. That's it.
Did everyone hear the question? He's asking if it's better to have a big...
Shall I repeat myself?
Yeah, go ahead.
Full-size floor standers versus stand mount speakers without board subs. Any comments?
I think anytime you have all of the transducers in one large enclosure, you're not really occupying any more floor space, and there's lots of things you can optimize, and I think that's strongly in favor of a properly designed full-range loudspeaker.
Well, this is another area with audiophile prejudices that I don't agree with. You should have separate subwoofers for myriad reasons in my mind, particularly if you use 4 of them. You can eliminate half your room modes. You get a lot of free bass from the boundary reinforcement from the walls. And then you have the flexibility in placing your speakers that work above the crossover point with the concern of a more limited bandwidth. So you may not have to place them poorly in order to get the lower bass to work. And you can be more concerned with placement aspects like imaging, et cetera. That assumes that you have a really good EQ system for both that will help with the transition working properly so that they blend together seamlessly.
Well, in the words of Gilbert Briggs a long time ago, a good big un always beat a good little un. So in that sense, good. But partly what Kevin said, in terms of having outboard subwoofers, they can have advantages in loading the room, but the problem is we give that job of integration often to the customer. Now, you want flexibility to be able to match to the room, but we have a difficult enough time integrating all our drivers together to make them to sound uniform, like Michael was saying. And that extends to the very critical mid-bass region crossing over from mid-bass to subwoofer. So to give that part up, as we seem to do traditionally with, oh, buy a subwoofer, and oh, it's got frequency controls on, and oh, put a little bit of EQ here and there, that's not so good. If we engineer it as a complete package, that's a different question, and I think it can definitely have advantages.
I think it's a very difficult question, actually, because both approaches can yield very good results. The thing is that when you really want to do a full-range speaker that has to extend low, maybe not as low as 16 hertz, but down to 20 maybe, then you need a huge membrane area, you need a huge speaker, and of course, what comes out in the other end of that is something that is financially out of reach of most people. And you can't create very intimate, very, very good results with tiny speakers. So from a performance point of view, it's a little bit like this. You have the flexibility with the subwoofers, build it into the room, make it look nice, but you have the scale and the slam and the integration with the big speakers. So I think it's not either or, it's both. You need both.
Well, like my Asian dealers say, everybody come in. They have a lot of money. Some have a small room, some of them have a big room. You need a compact mini speaker for the small room, and price is no object. If a customer has a big room, he wants a big speaker. He said, so you got to make both. Now, I think there's advantages to both models. Like Kevin, I'm all with the idea of loading the room uniformly with equal pressure. So I really dig the idea of having at least a front and rear sub. 4 is better, 1 in each corner. But how many people are going to do that? It's hard enough to get a home theater guy interested in 4 subs, much less an audiophile. So I don't know. I would say our market, even though we make 19 different models and probably a third of them are minis, I would say our big speakers sell 90% of our output. So it's up to the customer, really.
I think the bottom line is that they're, depending on the application, both are necessary. I mean, I could repeat word for word what Kevin said because I agree with exactly what he said, but there is applications for small speakers in smaller rooms and desktop systems and recording studios. It's really important. For making state-of-the-art speakers, small speakers just don't make it. They can't handle the power. They can't do a lot of the things that the larger speaker does, so it depends on the application. If you're looking for state-of-the-art, it's definitely not a speaker on a stand.
Well, it looks like we're about out of time.
We are now.
So before we go, I'd like to tell you about the Absolute Sound's Illustrated History of High-End Audio. We did a complete definitive history on high-end audio loudspeakers, and all of these loudspeaker designers are featured in the book. So we have them on sale outside the ballroom, and I'm sure that these gentlemen would be happy to sign a copy if you're interested in getting one. So with that, I'd like to thank the panelists for an interesting discussion.
Thank you.